Good afternoon, everyone, and welcome to the Q&A session 17 from the playlist of electrostatic potential and capacitance. The topic is the loss of energy due to the sharing of charges. And based on this topic, I have selected one question for this session, which was asked in the NEET examination in the year 2016. So the question here is, a 2 microfarad capacitor is charged as shown in this figure, and the percentage loss of energy when the switch S is turned on to the position number 2 is. So there are four options available, and we have to find the correct one. So the initial charge on the 2 microfarad capacitor, let us say initial charge on 2 microfarad capacitor, this will be equal to Q will be equal to C into V. So here the capacitance is equal to 2 into 10 to the power minus 6 farad into V, and the initial energy stored in the 2 microfarad capacitor in the position 1. Initial energy stored in 2 microfarad capacitor, say it is equal to Ui. This will be equal to half Cv square. C is equal to 2 into 10 to the power minus 6 farad and into V square. So this is the value of Ui. So I will be writing the value of the initial energy which is stored in the 2 microfarad capacitor in the position 1 when the switch is turned towards the position number 1. So this is equal to half, or we can simply write it as 2 into this 1 by 2 into 2 will get cancelled out. So this will be equal to 10 to the power minus 6 into V square. Now, when the switch is turned to the position number 2, then these two capacitors will be in parallel, and the charge which is stored on this 2 microfarad capacitor will be now shared among these two capacitors, that is the 2 microfarad capacitor and the 8 microfarad capacitor, till a common potential, or you can say a common till a common potential is attained. So in this case we have to find the value of the common potential. Let us say Vc is the common potential attained when the switch S is turned to the position number 2. So this common potential will be equal to total charge divided by the equivalent capacitance. So the total charge is equal to, is given here as 2 into 10 to the power minus 6 V, 2 into 10 to the power minus 6 into V. This is the total charge divided by equivalent capacitance. Now equivalent capacitance in this case will be equal to, after the switch is turned to the position number 2, then these two charges will be in parallel, and the equivalent capacitance will be equal to 8 plus 2 into 10 to the power minus 6. This is the equivalent capacitance, because these two capacitors will be in parallel when the switch is turned to the position number 2. So from here we can simply find the common potential, that is equal to, this will get cancelled out, and this will be equal to 2 by 10, or you can say it will be equal to V upon 5. So the common potential will be equal to V upon 5. So the final energy which will be stored among this combination of capacitors will be equal to, I will just write the value of this initial charge here, Qi. I'm just writing the value of the initial charge on this 2 microfarad capacitor when the switch um, was towards the point 1. So this is equal to 2 into 10 to the power 6. 2 into 10 to the power minus 6 into V. Into V. Now, the initial energy which was stored in the 2 microfarad capacitor is given to us here. Let us say this is the equation number 1. Now, we will find the final energy between these two, or can say between this combination of capacitors. This will be equal to half CV. Now, CV will be the equivalent capacitance. So, the equivalent capacitance will be equal to 2 plus 8. That is equal to 10 into 10 to the power minus 6. Half CV square. And V will be the common potential. So, this will be equal to V square upon 25. So, this is the final energy which will be stored in this combination of capacitors, that is 2 microfarad and 8 microfarad, when the switch is turned towards the position number 2. So here the common potential was equal to V by 5. So the percentage loss of energy, this will be equal to Ui minus Uf, where Ui is the initial energy stored in the 2 microfarad capacitor when the switch was turned towards the position number 1, and Uf is the total energy which is stored among these two capacitors, or can say among this combination of capacitors of 2 microfarad and 8 microfarad when the switch was turned towards the position number 2 into, so Ui minus Uf divided by Ui into 100. So this is equal to, now Ui was equal to 10 to the power minus 6 V square divided by 10 to the power minus 6, minus Uf. Uf is equal to, from here I can just simply find the value here. This will get cancelled out, 5, and this will get 5. So this is equal to 10 to the power minus 6 V square upon 5. V square divided by 5 divided by Ui, which is equal to 10 to the power minus 6 V square. And this will be into 100. So from here, the value of this percentage loss will be equal to, the 10 to the power minus 6 V square is common, so it will be cancelled out, and I will be left with the 1 minus 1 by 5, 1 divided by 1 minus 1 by 5 divided by 1 into 100. So this will be equal to 4 by 5 into 100. So this will be equal to 80. So the percentage loss due to the shading of charges when the switch S was turned towards the point number 2, it will be equal to 80%. So the correct option here is C. So here the most important thing which we have to remember is that we have to find the common potential once the switch is turned towards the point number 2. In that case, the common potential came out to be equal to V upon 5, and then we have to also find the equivalent capacitance when the switch was turned towards the point number 2. So after finding the equivalent capacitance and the common potential, we were able to find the final energy which was stored among this combination of capacitors. So, and by using the formula, that is this loss of energy is equal to initial energy which was stored in the 2 microfarad capacitor minus the final energy which is stored among this combination capacitor when the switch S was turned towards this point number 2, divided by Ui into 100. So the value of this is equal to 80%. So the correct option here is C. So thank you very much for joining this session. And the next session, I will be coming up with a different topic from the same chapter, that is electrostatic potential and capacitance. So till then, have a nice day. Bye.